When you have followed my channel, you will surely know that I was busy in the past weeks with this oscillator. It is a 2-transistor oscillator, and in the earlier video I have showed that you can use that with a constant current source. But anyway, that is of course a very good option to make such an oscillator. Now I was working further on that circuit, and I made it now in another way. Now I will give the schematic, of course, and I made it in such a way that I can now change the emitter resistance, the collector resistance, etc. And that means that with these two transistors here in that multi-vibrator circuit, you can get to all kinds of other frequencies and especially other waveforms. And that is of course interesting. When you want to do certain experiments, could be that you need a certain waveform, be it a needle wave or other kind of wave, and you can, in this case, and I will publish the schematic as soon as possible when all is say worked out. You can change the waveform, and want to give a kind of demonstration here. This is now the waveform on 93 kilohertz, and this is the waveform. But when I turn these knobs here, you can change it, and well, let me show it. This, of course, on a certain moment the oscillator stops. So there is a kind of bandwidth here when turning this where the oscillator works. But anyway, give the scope some more amplification. And well, I cannot take a deep dive into all the waveforms that are, say, can be generated here. Going from, say, a triangle wave here to other waveforms, but the focus in this video, and now we are on 252 kilohertz, the focus on this video is in the say the second stage of that oscillator. And I found, for instance, here, not the frequency by the way, 134 kilohertz, and I found that it was very difficult to take out the signal out of this in fact very simple 2-transistor multi-vibrator circuit. And after many experiments I found that, say, the grounded base circuit worked best, and that's, say, the kind of idea of this video. 1-transistor grounded base circuit, and this is what I have made. And when you have say some idea about all the earlier videos that I published on YouTube, say there are approximately 1500 videos there, and in many videos I have paid attention to the bias of a 1-transistor circuit, and especially here we now have to do with a grounded base, and well, it looks a little bit like a grounded emitter circuit, and that's say in many ways published on my YouTube channel. But now you see here that the base of the transistor is grounded via a 100 nano farad capacitor, and we send in the signal to the emitter. And you can set here the bias, and that's say, of course, in a kind of way logical. The bias of one transistor circuit can always be set to a certain value. And when I talk about value, I mean the way that the transistor circuit amplifies waveforms. And in this case, it is this oscillator here. It's a multivibrator. Well, let me show, by the way, the very importance of biasing the grounded base circuit. The biasing of a grounded emitter circuit is also very important. You will surely see when you change the value of this potentiometer, it biases the transistor, and the waveform changes, the properties of the waveform change. Well, the purity of the waveform changes, etc., etc. And well, I have to take a screwdriver now to move here that potentiometer. Anyway, take some time, of course. Anyway, well, so now I'm going to bias here that potentiometer, and let us look at the same time on to the oscilloscope views. When say the voltages inside this grounded base circuit change. Anyway, it's very important. Here I'm doing that now. Let's see what happens. We are on 130 kilohertz. This is the waveform, and now I change that potentiometer. You can surely see here what happens. The waveform changes completely. So now we have a kind of not a triangle wave, but anyway, here it looks a little bit. No, it's not a square wave anyway. And also the frequency changes. 205 kilohertz, and this is the waveform. And well, let me do it again. 180 or 168 kilohertz, and well, anyway, so what I wanted to tell is that via biasing here, and also in this case, it could be that when you have another completely other circuit, say another square wave oscillator or whatever, it could be that these things don't happen, but in this case it happens. And well, the whole idea is again to tell something about a grounded base circuit. Thanks for watching. And in the grounded base circuit we add the signal to the emitter. It's amplified here at the collector, and say there is a capacitor here from the base to the ground, and in this case that is minus. And of course there could be circuits where you use a PNP transistor and the ground is not minus but positive anyway. So that are my experiences. Want to go to say the highest frequency that this oscillator can give. Let me try. My camera gives 15 minutes, so I can try some things. Well, let's see. The waveform and the frequency, that's interesting. (42 kilohertz, good waveform. And now let me change the bias of the grounded base transistor stage. Well, that could be interesting. Let's see. So there is a certain position of that potentiometer here where that bias works very good. So anyway, let's see further. Let's go to the highest possible frequencies. Well, anyway, 386 kilohertz and this waveform, and now let me say set the bias of that one transistor base grounded base circuit again. So do your own studies. It could be a very, very helpful circuit. And that's all that I wanted to say.